Hi, Honors Algebra. We are on section 1.5, compound inequalities. So today our objective is to talk about exactly what a compound inequality is and how to determine the intersection or union of two sets. And then we're going to solve inequalities involving and ors, and then solving word problems. That will be on day 2. All right, so before we begin with this review and examples, first let's talk about the difference between the word intersection or union. So intersection, like if we're going to talk about two sets, I believe when you were younger you used Venn diagrams. So for example, if I have this set A represented by all the elements in the circle, and I have a set B represented by all the elements in this circle. The word intersection means where they intersect, where they overlap, where they meet. So I'm actually talking about all of these elements inside here. So where set A intersects or overlaps with set B. And there's a symbol for that. So by the way, this is an intersection. When we say and, A, where the elements are in set A and also in set B, this is what we mean. They have to be in both. They have to overlap. We normally symbolize that by an upside down U. Okay, now the union, so by the way, an intersection is an upside down U. Now the union of two sets is a little different. So let's pretend those are all the elements of set A, and this circle represents all the elements of set B. So in that case, what we want to do, if I want to find out where A unites with B, notice that it is actually a U. I want to know where A unites with B. That means it could be in set A, or it could be in set B, or both. They could be in set A and B. So when we talk about a union, we're asking us where they actually unite. So the union represents where they unite, and that's also represented by the word or. So for intersection, we're talking about the word and. So where are all the elements of A and also in B? They're only here in the middle where they overlap. When we're talking about the union of two sets, we're asking them to unite them, put them together. So they could be in either set A, or they can be in set B, or both. So the word and is related to the word intersection, which is A intersecting with set B, and the union of those sets is the word or, and that means where A unites with B. So both of them together. So hopefully this helps. Now, that aside, let's go to reviewing of some set builder notation and the roster method to represent the set of all integers between -2 and 5. So remember with set builder notation, we're basically saying the set of all x values such that. Now since they want us to tell all the integers between -2 and 5, we know that all the integers would be the set of all x values such that x is equal to, now since it has to be between -2 and 5, it doesn't include -2 and +5. It's all the integers between that, which would be -1, 0, 1, 2, 3, and 4. And those are all the elements or solutions of that set. So that's set builder notation. The roster method is basically telling us what are our solutions, period, that'll work. So the roster method is basically saying x has to equal -1 or 0 or 1, 2, 3, or 4. So it's just the way the answers are presented. That's the only difference. So set builder notation looks like that, and the roster method looks like that. So if you look here, this is really the roster method right here. It's just that you're not saying the set of all x values such that x has to equal. This is a roster method saying use A. Now it looks like you're saying just use A, but what you're really saying is use set A. So when your example appears like that, what they really mean is use set A. So what they're saying is if set A contains all of these elements, -3, -2, -1, 0, 1, 2, 3, and set B contains all of these elements, 0, 2, 4, 6, they want you to find each of the following. So again, we have this funny looking symbol. And if you recall, we said, hey, that upside down U is really intersect. So how you can remember this, maybe just a little trick. N in the word intersection, this looks like an N, so that's and, okay? And then U for union is your unite. So you're bringing those together. So this means A intersecting with set B, and this is A uniting with set B. So kind of remember that when you're actually doing this problem. So here, they want you to find the solution to where A intersects with set B. So what are all the elements that are contained in set A and at the same time in set B? Well, if we look at each of our sets, we can see that there are some overlapping numbers. We have that a set A contains what elements also in set B? Well, we see that the number 0 is also in set A and B. Unfortunately, -3, -2, and -1 are not contained in set B, so that cannot be an answer. 1 is not, but 2 is. 2 is also contained in set A and B, and that looks like it. So the intersection of set A intersecting with set B would be the solutions 0 and 2. So we're just going to separate them with a comma, and that's it. So those are our solutions. Now, A united with B means what elements are in A and also, or I should say, or also in set B. Since uniting means or bring together, that means I want all the elements in A, or I want all the elements in B, or both. So that means we are going to bring all of these answers together. Now, we know that there's some overlapping ones. We don't need to state them twice. So all we're going to do then is state them in order. And of course, it's descending the smallest number first to highest, so we're going to put it in ascending order. So we have -3, we have -2, we have -1, we have 0, we have 1, we have 2, we have 3, 4, and then 6. So some of these elements are from set A, the others are from set B, but uniting them all together puts them all as a solution. So that's the difference between uniting or intersecting. So just a kind of reminder over here, if I see the N here, that means to intersect. So I'm looking to see where they overlap. Okay? If I'm looking for the union, I want to know where they unite or where they come together. All right? So I want to combine. And that's it. So just know the difference in the symbols. Okay? So those are our examples for those problems. Now, again here, they're saying use C, which really means use set C. So they're telling us that this is the solution to set C, this is set D, and this is set E. They want us to graph the solution set to each of the following. Then state your answer in interval notation. Okay, so right now they want us to intersect set C with set D. So that means set C intersecting with set D, what are all the elements that are in set C and also in set D? Because remember, the word intersect also means and. So we have to find where they overlap. So the first thing we're going to do is we're going to graph set C. So according to this, they're telling us that set C is the set of all x values such that x is greater than or equal to -4. So what I want to do here is I'm going to put the name of the set over here. I'm going to graph the solution to this set. So that means on some graph line here, if all of my x values have to be greater than or equal to -4, well, I'm going to put a 0 here, and here's -4. So all of my x values that are greater than or equal to -4, that means -4 is part of that answer. I am going to put a bracket because I know a bracket means that it's included. And all of my values greater than that is going to be in this direction. So this is the graph to this set. That's what it looks like. Now, since they want me to find the intersection of set C and D, what I'm going to do right directly below it, I'm going to graph set D. If you keep your work organized like I am, one on top of the other, you should not have any issues. If you're going to put them next to each other, you're not going to see the connection. So I'm going to tell you and encourage you, please do exactly how I am, which is write your graphs and draw them right directly below each other. Okay, so from this point, what I'm going to do, I'm going to, again, make a line. And what you want to do, very important, is align your numbers as well. So if you see from set C, my 0 is here, I'm going to want to make sure that my 0 for set D is in the exact same location, just obviously right below it, that set C was in. Okay, so according to set D, I need all the x values such that x is less than 1. So 1 on my number line would be about right here. Now all my x values less than 1, but do not include 1, mean that I have an open interval at 1, but all my x values less than that go on forever in the negative direction. So there is my answer to set D. That's the graph to set D. However, we didn't even touch this yet. They want to know where is the intersection of both sets. In other words, where do they overlap? Where do they meet? Well, set C starts here at -4 and goes on forever towards infinity. And set D goes from -infinity all the way up to, but not including 1. So really they're overlapping right there. Because if you see, this is where they overlap, and they overlap at -4. This is -4 here, and this is all the way up until 1. So if I were to draw where they both intersect, set C is intersecting with set D, here's 0, here's -4, and here's +1. So I want to grab everything that I graphed from -4, which by the way was an actual bracket at -4, and unfortunately it does not include 1, so everything up to that was shaded. And if you see the overlapping, I can't keep this part because this is not graphed in set D. I cannot keep this part of set D because this was not graphed in set C. The only overlapping that took place in both because remember, intersection means where they both overlap, is everything between -4 and 1. -4 included, 1 not. So we have a closed interval at -4 and an open interval at +1. So that's my graph, that's my solution. So how I need to write that then in interval notation would be exactly, I'm going to use my open and closed intervals here. So I have a closed interval at -4 all the way up through, but not including 1. So I have an open interval right there. So that's how I'm going to write my answer in interval notation, and this is how I graph my answer. Okay? So we're going to move on. Now, if you look, the problem is, what about set C uniting with set E? So again, what I'm going to do separately is graph each of those. So I'm going to graph set C, but the good thing is once you've graphed set C, it's the same graph. So I'm just going to, you could kind of tell, okay, I have 0 here, and I know that set C has -4, and I know that all my x values that are greater than or equal to -4, so there's set C. We did that before there. Set E, however, is a little different. So set E, we're going to put directly below it, and remember, you want to align up your numbers. So if 0 is here, I want to put 0 in the same place. For set E, all my values are greater than 2. So here's 1, here's about 2. Can I guesstimate? And everything greater than that, that means I have an open interval at 2, and everything greater than that is to the right. So because I'm uniting both of these graphs, I want all of it. So the solution then to set C united with set E, I know it looks like the word Q, is basically going to be, let's see, set C starts at -4. So I have a closed interval there, and it goes all the way towards infinity. Set E starts at 2, but goes all the way towards infinity. So since uniting means bring together, I want both graphs together on one graph. So that means here is C's graph, and here is E's graph. Now if you look, we already have 2 included there, and so from this part on, it's just an overlapping thing. But since it's united, we want both. We want everything, because unite means bring it all together. Bring this graph together with this graph, and therefore you'll have all of this graph. So we don't need to put an open interval here because it was included in C's, so it like overrides it not being from E. So this is our final graph for set C united with E. Now, to write this solution in interval notation, again, you write it from lowest value, which is -4, all the way to the highest value, which happens to be infinity. And remember, you never reach infinity, so you can't include it if you never reach it. It's unbounded. So there's our solution set. Okay? Now for part C, we want set D united with E. So again, if you graph these separately, so set D, we did down here, but if we could, we want all our x values. So again, label your graph that are less than 1. So that means 1 is not included, but everything less than that is going in this direction. We have an open interval there. And then we want to use set E. So set E, we're going to put directly below it. And again, remember, you want to align your numbers. I can't stress that enough. I hope, whether or not it sounds repetitive, you really want to keep your numbers aligned, because if you don't, you're not going to see where everything overlaps, and that's going to be really tough to figure out where the graphing takes place when you're finding the union or the intersection of both sets. Okay, so set E tells us I want all my values greater than 2. Well, here's 1, so 1 would be about here also on this graph. So 2 is somewhere over here, okay? So all my values of x greater than 2, not including 2, will be going to the right. So because I want the union of set D and E, that means together, so D united with set E, that means that graph, 0, 1, and 2, I just want to put both of them on here. So D's graph goes from, I'm going to change color there, from negative infinity all the way up till 1, not including 1. E's graph starts at 2 and goes to infinity. So that means this is the solution set where they unite. D's graph united with E's graph put together will give you this graph. So the way we write this solution, well, again, smallest to greatest number. The smallest number is negative infinity. So negative infinity is unbounded, so it has to be an open interval there. All the way up to, but not including 1. So we have a totally open interval here. But then we have to unite that with this graph. So between that, we're going to write the symbol U for unite. And this graph here, this solution goes from 2 all the way up through infinity. And again, 2 is not included in that solution. So this is actually how we're going to write this compound answer here. Okay? And finally, they want us to write where the D intersects with set E. Well, here's D, and here's intersecting with E. So again, we could just recopy this here. But here's D's graph. And I'm going to draw E's directly below it. So I want to align my numbers 0, 0, and 1. And all of my values less than 1 are getting shaded to the right. And for set E, it's, again, I want to align my numbers. So for set E, here's 1. That means 2 is somewhere over here. And all of my values greater than 2, but not including 2,